Hey guys, welcome back to part 2 of the first MonoBlock PC build. So last time we made this prototype from plywood and 3D printed parts, and the first thing we need to do is assess this and make any changes that we need to. So right away, one of the issues you may have seen is that there's actually not enough space between the top panel and the GPU plate in here for a riser cable to come over the top. So first thing we're going to do is add a couple of mil in height to these three pieces here, which will raise the whole top up by 2 mil, which should be enough for a riser cable to go over the top between this and the layer underneath. So here we have the CAD model, and I'm just going to extend these pieces now slightly. Okay, so that is done. The height before was 81 millimeters, it is now 83. So we've added a bit of volume, but I've seen another way that we can reduce the volume by reducing one of the other dimensions. Let me show you what I'm thinking. So here's where I think we can save some space. Now we've left a gap either side of the motherboard, so down here and down here. And the reason for the gap on this side was to allow the copper pipes to travel down the side and come out the inlet and outlet holes here. But I still think we could probably take, if we lower these holes down slightly so they're not going to interfere with the mounting thread of the top panel, because the thread obviously needs some depth. So taking maybe a centimetre off here would push the holes over into the path of this hole. So if we bring these holes down, that's not going to interfere with anything on the side. We've got the riser, the PCIe port here, but the riser cable is going to come straight up and move out of the way. So we've got plenty of space still to bring these holes down a bit, which will allow them to go underneath this thread. And I think we can take a centimetre off this side. Okay, here we go. So the overall size now is 83 by 200 by 340. Yeah. So the volume of the case is now 5.6 litres, 5.64 litres. So we've come down in size, which is cool. We've come down in size while adding height to it. So back over here, what we've actually done is taken a centimetre entirely off this side. So what that means is, if we go over to the power supply and pump end, as we've already decided, we definitely need a smaller pump. So what I'm going to do for prototyping now is take the pump top off and basically base the dimensions of what we're doing on the bottom of the pump only, while we work on our own custom pump top. So we're going to use this. These all have threaded M4, I believe, holes on the inside of these fixings. So the pump is going to be mounted to the bottom of the frame, to the bottom of the case, via those 4 fixings and nothing else. So I'm going to take the pump top off just so we can mock up where the fixings are going to be. So we have the top of the DDC pump removed. You can see just how much smaller it is now. And since we're taking a centimetre off the edge of this edge of the case, I have laid out my power supply to be 15 millimeters from the edge, so that there's a 5 mil gap from the edge of the power supply to the edge of the finished case, or the next prototype of the case. The pump can then be right up next to the power supply. I've left a gap of a couple of millimeters there. And then there's another 5 mil on this side. So the next step is going to be to finalize all the fixing points on this bottom face. So all the parts here, the monoblock assembly, the power supply and the pump, are all going to be fixed entirely by this bottom plate here. There's not going to be any brackets or anything coming up. So the pump, as I said, will be fixed in by the female threads in the 4 feet here. The monoblock, now this is an advantage we haven't really talked about much. Just put the camera here to show you. A lot of people have asked, is it okay to hang 2.5 kilograms of copper off the middle of a motherboard? And you don't need to, because if we pick this up, the motherboard bracket supplied with the monoblock has these 4 holes here. 1, 2, 3, 4. And let me just go get a bracket for you to look at. They are countersunk from the inside. These 4. So the idea is that the bracket itself can be mounted to the case like this, screwed in, and then the whole monoblock is attached to this, and the motherboard essentially becomes a floating plane in the middle of the block. So the block is taking all the weight. So we don't have to deal with the 4 little motherboard standoffs here and then the motherboard flexing from this huge mass of copper, because the huge mass of copper is actually holding the motherboard up. So what I need to do is figure out where those 4 holes are on here so I can mark them out onto this piece of wood, figure out where the holes are for the pump and how we're going to mount the power supply, and put that into the CAD model basically, so then we can get a more accurate prototype of this bottom piece here. So I will attempt to do that now. So I've used this ruler to mark out roughly where this sits on the bottom of that block there. It's not going to be perfectly square because I'm lining it up against 3D printed parts, but it should give me a good idea of where the holes should be, and then when I put it in the CAD software I can make sure the holes are square and parallel with each edge. So I'm just going to mark out where these holes are, and then we'll move on to the pump and the power supply. So for the power supply, I'm just going to draw a square around it, just to get the location correct. And the pump, I've actually taken the working part of the pump out, so it is just a metal shell now. I'm just going to get it where I want it and do a bit of a bodge here, but a perfectly functional one. And just lightly hammer the end of all those fixings in the hope that they have imprinted onto the wood where the fixings should be. There we go, so that's where our 4 holes are. And obviously all of this is fairly inaccurate, but I can't really think of a better way to do it, so we're going to do this. And then we have a laser cutter, so the next version of this bottom piece, we're going to laser cut it with all the holes in the right places. And then if something's 1mm, 2mm off where we want it, then we can just tweak that. but we need kind of a baseline to start with so that we know which way to shift things around. So this is the best way I can think of to do this. So I'm going to take this piece with everything marked out. I am then going to transfer the position of these holes based off this edge, because this edge is coming in by 10 mil, so this edge isn't accurate anymore. Based off this edge and this edge, I'm going to measure to the position of each of the holes and get the CAD file updated. And I'll quickly explain how I plan to mount the power supply as well. So the power supply, the fixings are all on this face here. So you've got 1, 2, 3, 1, 2, 3. And you may have seen in our model here these two pillar pieces, which I haven't really explained yet. So the idea is basically to get those two pieces machined from aluminium, mount them to here, and have a nice big M6 fixing in the bottom of each one, which will bolt down to the case. There are these two holes here in the bottom of the power supply, but they're quite weak and there aren't any on this side, so I don't really like the idea of bolting this down, having it able to kind of flap around and slowly bend this bottom sheet. I'd much rather have a more substantial thing mounted to the outside and then bolted to the bottom more strongly. It still will only be mounted by this side, so it might have a bit of flex in it, but it's going to be a lot better that being braced against this side than it is just a flimsy M3 or M4 screw in the bottom here. So that is the bottom piece modelled up. You can see there are two holes at the top here for the power supply. We got these 4 holes for the pump, and then we have these 4 holes for the monoblock mount. So I'm going to send these over to Dean. Dean has the laser cutter. Dean and I actually live about an hour and a half apart from each other, so it's only every week or so that we actually see each other and build things. The rest of the time we need to communicate remotely. So I'm going to send this to Dean, he's going to laser cut this, and I'm going to send the new other pieces, which are these three pieces. He's going to print those, he's going to laser cut this, and then we will reassemble the prototype and see where we're at. But before I send those to Dean, I am also going to work on the pump top. So the idea with the DDC pump top is to just make it smaller. We've got our Alpha Cool one, as you've seen, which is unnecessarily big. So we are looking to essentially make the best or the smallest pump top with no compromises on the water flow. So we're going to go back over to Fusion and try and make that happen. So here is the pump top, the DDC pump top design that we've come up with. So dimensionally it's 60 millimeters by 60 millimeters compared to this Alpha Cool one, which is 80 millimeters. So our design fits entirely within the footprint of a standard DDC pump. It doesn't overhang at all. And the height is 20 millimeters. And we've managed to do that while keeping the fixings on the side, because we didn't want to have to deal with plumbing on the top, because it's going to use up a lot of height within the case. So just going through a few details, the way these pumps work, these pump tops, is, I don't know if you can see that, the water comes in through this central hole in the top. That's why they usually have a fixing on the top like this for the water to come in. So it comes in here and then is spun around by the rotating part of the pump, and it's flung out through that hole there. So that's the exit port. And the majority of these pumps, the way they're made, leaves quite a sharp edge here. Do you see that? This right angled edge here. So that quite badly is going to disrupt the smooth flow of the water. So the water's going to be spinning around and it's going to go over this sharp edge. So if you think of the aerodynamics on a car, if you have a flat square edge on the front or the back of the car, it's bad for the flow of air around it. So it's the same theory here. So this flat edge is going to make the water flow less efficient as it comes out of here. So what we've done, and the machining of this is going to be quite tricky because there's compound angles everywhere. Our exit port comes in at an angle like this, so that the point where it meets the rotating water, there is no sharp edge. It smoothly transitions into the exit port. And then on the inlet port, to make sure that we're not restricting the flow of water at all, we've got 2 holes drilled overlapping each other just to increase the cross-sectional area of the water channel inside. And so the water goes in here and then smoothly gets pushed around this edge. So it's got a nice smooth curve into the inlet port here. So basically there's going to be there's going to be minimal turbulence compared to any other pump top with side entry ports. Like I said, the machining of that is going to be quite difficult because this one you have an angle this way and an angle this way. So there's going to need to be jigs made up to be able to drill these accurately in the correct locations. But the overall design we think is pretty much perfect. There's no way we can improve that and keep this form factor. So 60mm by 60mm by 20mm. As far as we know, there is nothing else on the market that size without quite major compromises in terms of water flow. So I'm going to send that over to Dean and he's going to 3D print that. We'll check it works dimensionally and then we'll move on to machining a prototype.
Hi guys, Dean here. So the print's fairly straightforward, easy. But we had a bit of issue with the laser cutting on this 6mm plywood, but we'll get back to that later. First, so to take Felix's CAD file out of Fusion 360 and put it into Ultimaker Cura, this is the software we use to slice and print the 3D printed part. I'm using an Ultimaker 2 and the plastic we're using is black PLA. It's a fairly easy plastic to print, and other than waiting around for the 3D printer to finish doing its thing, it was a fairly straightforward process. Okay, now for the interesting part, the laser cutting of the top and bottom case panels. Now, on this revision, I just used the wood saw to cut through this, the table saw to cut the top and bottom panel. It's straightforward, it's easy, but I thought I could save time by using the laser cutter to not only cut out this piece, but also to cut out the holes for the case supports and also for our motherboard standoffs. It's a good idea in theory because you can do it all in one pass, let the machine do the work, and you're left with a nice laser cut piece. But getting this piece wasn't easy. It took a few more passes to cut out the perimeter than I'd expected. And not only that, but it's actually burnt through the wood where the hole meets the perimeter of this panel. And that's not good. It doesn't look good, and the structural integrity of that hole is compromised. So I'm not happy with that. In the end, what we opted to do was just to mark out the holes and the perimeter of the panel with the laser cutter, and that way we can just put it up to the table saw, cut through it, center punch our holes, drill them out by hand, and we've saved time by doing it that way, but we've added an additional step. And the final piece to the puzzle, back to the 3D printer, we've got the new DDC pump top going in. Now this, as Felix has shown you, is a lot smaller than our current Alpha Core one. Again, this printed really easily, no issues, same black PLA plastic. When it came off the printer, I even wondered if we could actually use this to water cool, but for now it's just a prop. So that's it. We've got the 3D printed parts for the case and the pump top, and the laser cut pieces for the top and bottom panels of the case. We'll get these over to Felix, he'll assemble them, and we'll see how it turns out.
So I was far too eager to carry on with the build that I actually took the 3-hour return trip drive to Dean's place on Sunday afternoon and brought the parts back. So I'm just cutting out the outside edge with my circular saw, and then I'm rounding over the edges on my disc sander. Watching this video back, I didn't realise how much dust I was making, so I'll definitely do this outside next time. And I just finished the edges off with a sanding block, and then center punch and drill and countersink all the holes, and those pieces are done. Okay, so that is the plywood pieces done, and I've also got the 3D prints from Dean, and I'm going to assemble these now. So here's a quick tip: if you are ever threading screws into 3D printed parts, you want to print it with the hole slightly undersized for the screw, so this isn't going to easily wind itself in. Just heat the screw up slightly and it will melt its way into a nice thread. Oh, hey bro. Did you message me?
Yeah.
Sorry.
That's all good.
Is it 1 o'clock already?
No, it's 12:30.
Oh, okay. The joys of having 3 jobs. So that was Mark, my business partner for one of my other businesses, and 8.5 hours have passed since then, but I'm carrying on. It's 9 p.m. But I'm so excited to see how this goes together that I am not stopping, so let's assemble this. So that's the main parts of the case together, and I can now show you the power supply mount. I haven't tried this myself yet, so if this doesn't work, I will edit it out, but hopefully it will. So we got these 2 pieces printed, and they have 3 holes down here to mount to the power supply. I've realised the main fixing hole at the bottom actually overlaps the bottom hole, so we're actually only going to use 2 of these holes. And these should just go on like this. So that's the bracket assembled. I think that actually looks pretty classy. So this will then bolt through from the bottom of the case. Seems to have worked perfectly. Had to deal with some of the minor inaccuracies of 3D printing, but once that started threading in, it's pretty well mounted considering that's plywood and plastic. So that's worked pretty well. So next up, before we get to the pump top, is the MonoBlock. So, after a lot of faffing about, I've used 4 M4 screws and I've got some little nuts on the bottom. And obviously this is just for prototyping because we're using 6mm thick wood, which you can't really attach anything to. So that's mounted on there nice and firmly. Let's build it up. Right, we have a slight issue. The motherboard is interfering with this piece, pushing it outwards like that. So that's going to be an issue with the motherboard positioning or with the precise machining of this piece. So I'm going to grind a bit off here and just get it to fit for now, and I will adjust it in CAD so that next time it works. Right, so I've ground that corner off. It looks a bit rough on here, but this sort of thing is completely normal during any kind of prototyping phase. So that now fits perfectly and avoids the motherboard. Perfect, so I'll build up the rest of the block now. Right, lovely. And that's all firmly mounted. The only thing bending is the actual case. Okay, pump top time. So here is Dean's beautifully printed DDC pump top. You can see the smoothness of the join between here and the exit port. No sharp edges there. And like Dean said, I think this might even be watertight, but I'm not going to risk it. Not with a 4090 anywhere nearby. So I just need to tap these threads properly to M4 and assemble the pump top onto the pump. Quick size comparison. Right, let's do it. So these holes are tapped and I'm just going to assemble the pump without the actual pump inside it. So we don't need to deal with the trailing wires. There we go. Lovely little pump top. So let's mount this to the case. And there we go. It looks like we've made pretty much no progress at all since the last episode, but we are getting closer and closer to a repeatable, sellable case. So everything lines up pretty nicely. That pump is just inside the edge of the case. Enough of a gap there. And that's about 5mm from the edge of the case as well. The power supply is a bit wonky. I think I just haven't drilled the holes in the exact location that I was meant to. But otherwise it's looking very neat. And I will just put the top on now just to check the space for a riser cable. Beautiful. Oh, you can't really see from there. So there is a gap there now. So it's all coming together pretty nicely. I feel like we're reaching the limit of what we can do with wood and plastic prototypes, and it's probably time to go for a machined version now. Something you might have noticed is we've left a fairly decent sized tunnel down the middle here. We might be able to reduce this dimension, like the overall length of it is currently 340mm from here to here. We might be able to take 10 or 15mm off that, but with it as it is all kind of flexy and everything not quite perfectly in line, I feel like we need to do a machined version to really know what it's going to be like once everything's plumbed in. Because the plumbing and the wiring is going to take up a lot of this kind of tunnel space through the middle. And then adding to that, we're running a 4090 and probably a 14900K, so this 850 watt power supply might not be enough. So there's a good chance we're going to have to use this, which is Cooler Master's V1300. As far as I know, the most powerful SFX power supply, but the disadvantage of this is if you look at the two side by side, the ports all stick out. That's obviously so that they could fit a bigger circuit in there. So then again, that is also going to be taking up quite a lot of space, or it's going to intrude on that available space anyway. So I think we will leave it there for this episode. So again, thank you so much for watching. We will be back once we have a nice machined metal case. And then after that, it's going to be plumbing, wiring, and we might potentially have to go through another couple of prototypes of the metal version of the case as well, just to finalise everything. But we might get lucky and it might be perfect first time. So we will see how it goes. Thank you so much. Sorry, it's been a bit of a long episode. Hope you've enjoyed it. Any questions, put them in the comments below, and we look forward to seeing you again. Cheers.